Hey, this homework, this video will help you on your homework immensely. So really listen in on this homework here. What we're going to do is show you how you can calculate a lot of the functions that you take for granted on your calculator. The calculator does, like if you hit the cosine of 30 degrees, it comes back with a number, but that number is calculated in one way, and basically what the calculator does is it generates a series of terms, right here, cosine, this, and it generates those terms and performs this calculation here. We have to show you what that exclamation point is, but it performs a calculation and you add up all those terms. If you have enough terms to add up, you get the answer displayed in your calculator. So the calculators are basically little computers that are designed to do a series of additions very quickly. So what we're going to do is concentrate on this one right here, e to the x. Now you're going to learn in calculus that e is a base that is used a lot in mathematics. We're not going to get into it here, but if you wanted to calculate e to the third power, x is 3, and in order to calculate e to the third, you need to go through this series of calculations. Add 1, start off with the sum equal to 1, plus 3 squared divided by 2 factorial. 2 factorial. Factorial is an operation that is on your most calculators, but it's an operation that's not really done too much in early math courses. A factorial is very simple. 2 times 1. 3 factorial is 3 times 2 times 1. 4 factorial, 4 times 3 times 2 times 1. Basically, that's the operation. You're multiplying all those numbers. Okay, and so basically what they're asking you to do is take the x, raise it to a power, and there's a pattern to these terms. X to the 6th, I can guarantee you, if you want the 6th term, 0, 1, 2, 3, 4, 5, 6 term, take x, raise it to the 6th power, divided by 6 factorial. Do that calculation and add it to the sum. Now make sure when you do your math, don't start defining x to be an integer. A lot of students like to define their variables to be integers. In this case, it's going to be a very damaging thing because remember, if you have an integer, well, 2 times 3 factorial, these factorials will be integers. Don't make the top part equal to an integer because an integer divided by an integer yields an integer. Generally, in this case, will be 0. Okay, there's no decimal part. So make sure you use doubles for x's. So let's take a look at how we would do this type of factorial here. And I have 2 versions in the source code here. Okay, this is the way I would write that in my comment. Let's see. Let's take a look. I have version 1 and version 2. I call the version 2 main 2 so that it doesn't conflict with the main method there. So, I want to calculate something, huh? E to the x, I need to enter x. That's all. We beat that to death. We prompt, we read a double, x. Okay. Now, what I'm going to do is pick 25 terms. That's what I'm going to do. I want to generate 25 of these terms. This is a term. Anything separated by plus and minus signs are terms. 1, 2, 3, 4 terms. We're going to have 25 terms. Okay, that's what I'm doing here. I is less than 25. I plus plus at the very bottom. Okay, once we're done, we will have 25 terms. How do you generate these terms? Well, what you're going to do is do this. Calculate the power numerator. Okay, basically what you're going to need to do is calculate first off the numerator, then the denominator, which is going to be a factorial, and then the term is a division of the two. So I know you could do math.pow. So you could, what I've got highlighted there can be substituted by math.pow, but I wanted to start showing you how to write your own little code here. So if you want to multiply something by itself, basically this code here is basically the numerator starts off at 1. I count off my term. If I is 10, I would like x to the 10. X to the 10. So I need to multiply numerator by x 10 times. Remember what this means. Take the old value of numerator, multiply it by x, and basically if I were 10, j goes from 0 to 10, not including 10. I would be doing this while loop 10 times. I would be multiplying numerator by x 10 times to generate x to the 10th power. Convince yourself that that's what this does. Okay, so I'm going to go back to what that's the cleaner version of this code. Numerator equals numerator. That's basically the same thing as what I had before. Now factorial is very easy to calculate. Now remember, I is telling you what term you're trying to calculate. If I is 10, you're trying to calculate the 10th term. Remember, there's a 0th term, but we're trying to calculate the 10th term. To do factorial, what you want to do is make sure that my denominator starts off at 1. Okay. Now in this case, I got to make sure j is equal to 1. We can't be 0 would kill a multiplication. So make sure j starts off at 1 because we want 1 times 2 times 3 times 4 all the way up to 10. So that's why I started off with 1 here. J is less than or equal to 10. Okay. Denominator equals the denominator times j, times 1, times 2, times 3. And then we're going to increment j for the next iteration. Now, to be consistent here, I'm not sure why I put the plus plus in front. It doesn't really matter. But for consistency's sake, if I have j plus plus up here, then let's be consistent. J plus plus there. I'm not sure why I did that, to tell you the truth. But it doesn't really matter. Okay, so now what have I done? I got the numerator, I got the denominator. My fraction, or actually, let's call this term. My term is equal to numerator divided by denominator, and sum up that term. See, sum is equal to 0. That's my term. Sum equals sum plus term. Go on to the next I. All within here, I never change I. So make sure you never change I, because I's value is supposed to control the number of times you do the loop. So let's see what happens here. At this point, I print out my value here, and let's see if that works. 1. And that does work. E to the 1 is this value right there. Punch that in the calculator. You're going to find that it does work. That's the value here. There's all, but like everything, this coding has already been done for you in the math library. There is a math.exp math.exp of x. Okay, and let's print this out because I got 1, 2, 3 values here. I need 3% signs here. Why don't I just put real value? I'm going to assume what's in the math library is better than what I got here. %.5f. Okay, so that's going to print out what the JDK has for an EXP. And now if I run this again, let's see, 1, and yeah, what we calculated here is the same thing as the real value. So I think it's pretty good. And basically, what this shows, it doesn't take many terms. It doesn't make very many terms. I mean, 25 terms to a computer isn't a lot. If I break this down to, say, only 6 terms, okay, then we're not generating enough terms to make it very accurate. Let's see what happens here. 1, and you can see that we're getting off here because we didn't generate enough terms compared to the real term. But even 6 terms, it gets you very close to the answer. So let's go back to 25. 25 should be enough. And the second version is basically, it's basically for loops. Okay, all these while loops are the same thing as for loops. Okay, and so I do the same basic computation. I do this. Look at how much cleaner it is. I want to do 20. See, the for loop is nice. Everything that has to do with the for loop and the iteration is done right in the for loop. Start off with 0, up to 25, I++. Okay, I would like to calculate the numerator, so it's basically another for loop. Okay, now here I have j defined here. J is defined within the for loop. That's nice because that j is only used within the for loop. If I wanted to, it's not, I cannot do something like this. I cannot say sys out j because j is not available. J is not defined. Okay, here's, if I hover over j, that j can only be used within the for loop. That's it, nowhere else. Okay, and so outside the for loop, it's not defined. Understand that. And a lot of times that's what you want. You don't want your variables polluting your variable space. Same thing here. Look, for doing the denominator. Start from 1 all the way up to I. Okay, j is equal to 1. We're going to multiply denominator by 1, 2, 3. Once we don't, outside that for loop, we don't need the value of j. So this j and this j are not the same j. Understand that. They're only defined within the for loop. You get the same answer. And we can go ahead and prove that by making this main, and we'll make this main 2, and let's run it. We have a different main, and we'll type in 1. Yep, there it is, same value of the code. Now, let's take a look at just one more. This should take a couple of minutes. That's all, combinations. And what you're going to do is learn about probability. And probability has this function, not in this class, but in a probability and statistics course. There's a variable or an equation that's called the combination equation. I won't get into it, but this is the combination equation right here, where take my word for it. If you C of n comma k is calculated by saying take n factorial, multiply it by k factorial times n minus k factorial. How do you do it? Well, look at this. N factorial, k factorial, nk factorial. You can see that we're doing the same thing over and over and over again. The same basic logic is being applied to calculate that. It'd be nice to bundle that logic in its own little sub-program. And in the next chapter, chapter 6, I'm going to show you how to do that. But this is how you do n factorial. The only real difference is the upper limit of the calculation. That's the only real difference. But once we got those values, we can perform this calculation here. And that's it. We can print out the combination. So you'll have to take on faith that this answer does work. So we'll stop the video here. And I just wanted to prepare you for the next video in Chapter 6, where we would take this similar calculation and make our own little method and have one piece of code that gets called 3 times to do the job. All right. Take care.